Hey guys, you're welcome back to analysis of vector from Mosdi Academy. And as well, so about product of vector, we categorize the product of vector into two categories in physics. The first category we call the scalar product. As you know, we said what we talk about product, which is simple as multiplication. We have a scalar product, and as well as the one we call the vector product. So these are the two categories of product of vectors. So when we are trying to multiply vectors together, you can either do it in scalar and also in vector. The scalar products popularly in your text materials are called what we call the dot product. So you can always keep that at the back of your mind. So another name for scalar product is dot product. Another name for vector product is called the cross product because of your examination, the cross product. So these are what we want to talk about. And majorly in this slide, we are going to focus on scalar products, and we are going to talk extensively with some examples and talk about one or two examples that we can solve in this particular slide. Now, about scalar products. Why do we call it a scalar product? The simple reason why we call it scalar product is because the product of these particular vectors are always going to be scalar. That is, it is always giving a result that is scalar. When I say scalar, I believe you understand that I mean having only what? Magnitude. So I'll just give an example because we have a lot to talk about in this particular slide. And be that as it may, let's talk about how do we denote scalar product. Now, for example, we take a vector, we say C vector, which is equals to the scalar product of A vector. You can see dots, that is why it is also called dot product. Then we have a B vector. So this illustration you can see here, my dear student, is called a scalar product because the multiplication of A and B vector are represented by dots. So therefore, in physics, we say the magnitude of C is now equals to the product of AB cos of theta. So what we are trying to say is that theta in this category we call what? Angle between vector A and vector B. So always keep this in mind because it's kind of very easy to forget this about the cosine of theta. So when we have two vectors which we are going to multiply by scalar product, we use dot in between them. And the overall result is always giving us C equals to AB cos theta. We are A and B that you see there, where the cos theta that is there means angles between the two vectors. So please always keep it at the back of your mind that scalar product of two perpendicular vectors is always zero. I think I should put that down for you because it's kind of important. I said the scalar product of two perpendicular vectors. Perpendicular vectors is always zero. As we have discussed in our previous slide, I told you about perpendicularity or normal. When you put that, that is at 90 degrees. Everybody should know that cos 90 is nothing but zero. So that is why we say when we are talking about two perpendicular vectors, their scalar product is always zero. So because of that, you can also write or keep this down as also a good note that the scalar product, because it will help us in our calculation, the scalar product of two identical vectors is equal to the square of its magnitude. So this is another important point we need to always keep at the back of your mind. What am I trying to say there? Maybe I should bring some light into that. Maybe we have two identical vectors. Let's say we have A vector. We have scalar product of A vector multiplied by A vector. Because we see they are always the same, it will be as in A times A. It's going to give us A square. So that is what I'm trying to say here. It's kind of very, very simple. And the most important one, because of numericals, when I say numericals, I mean calculation, is those one that involve the scalar product of unit vector. Remember the unit vector we discussed in the previous slides and section. We talk about the ijk vector, which are always in form of I cap, j cap, and k cap. So how do we multiply the product of our unit vector? That is what we want to talk about. Now, that one is quite important, and I want you guys to understand it, because most of your questions is going to learn what is going to what be around these categories. So because of that, we need to understand that concept very clearly. So about scalar product of unit vector, I just need to talk about that in quick one. Now, scalar product of unit vector. I know some of our students, you might have learned about it in your early classes. And for those who are yet to understand it very well, that is why we are doing the basis of vector, because we believe in a knowledge of physics and mathematics. This is very important. Now, when we talk about the scalar product of a unit vector, remember a unit vector, like we have already discussed. I'll just go like this. Say, let's say A cap has a unit vector of A. Scalar product is dot product multiplied by A cap. The logic is always, whenever we multiply two unit vectors together, it is always give us a result we call a unit. You understand? A unit which is always equals to 1. So for every standard unit vector, a quick one, for standard unit vector, so we take, whenever we have, the quick one you can always keep at the back of your mind. Whenever we have the I vector, I cap, which is the unit vector of I, being multiplied by what? By scalar product of I cap. That is I cap multiplied by I cap. You can also have when j cap multiplied by j cap, and when k cap also multiplied by k cap, that is scalar product, the result is always equals to 1. So keep that in mind. Whenever you are multiplying a unit vector of the same magnitude, it's always going to give you 1. That is the law about the scalar product of unit vector. There's nothing to worry about. But if you are doing the cross linkage between two unit vectors, we say those are perpendicular from the graph we've drawn in the previous slide. You know, for example, I say I'm multiplying I cap scalar product with j cap, or I'm multiplying j cap scalar product with k cap, and I'm also trying to multiply k cap scalar product with I cap. I'm going to have what? 0. But what I'm trying to say is what I've already said here, my dear students, that perpendicular vector are always 0, whereby the one that's identical is always giving us what? For what unit vector is always 1. So keep this in mind, because it's going to be what's needed when we do two numericals in this slide. So before we move to that, let's quickly talk about the last phase of this one before we do some maybe two calculations. We talk about what we call angles between two vectors. I think that is also important before we move to the calculation. So we talk about angles between vectors. About angle between vectors, we can quickly say we are talking about scalar multiplication. Let that sink. Now about that, if we take a vector, for example, we are multiplying a, or let's consider a and b vector, and if the result of multiplication is scalar product, like what we are talking about, so we don't need to waste our time in understanding these simple concepts. We say when we cross link, or when we multiply a vector scalar product, that is a dot product, with b vector, we say the answer of it is always scalar. Now I've given you the formula here. It's always going to give us AB cos theta, which we have discussed, because they are placed perpendicular to each other, and you can understand that this is the formula we use for angle between vector. But if you are talking about unit vector, remember we have talked about unit vector in the previous section. And about unit vector, I said whenever we divide vector divided by its own magnitude, we are going to have what we call what? Unit vector. In fact, in this formula directly, my dear students, I can make cos theta subject of the formula. So directly, because of time, cos theta here is going to give me vector A dot product B vector divided by AB. And if you can see, guys, vector divided by its magnitude, vector divided by its magnitude. And that is what we call unit vector. That means we have A cap dot B cap. So what I'm trying to say, guys, here is that whenever we are looking or we are asked to calculate the angle or looking for angle between vector, what we do in the dear student, is just for us to go by what the vector itself divided by its own magnitude, because this is vector, this is magnitude, and we've talked about magnitude of a vector as the square root of the square of each of the what vector. So please, these are what we are going to be considering in solving the two questions we have before us in the next slide, and before we call it a day in this particular what in this particular topic on product of scalar product. Now, about that, with what we have learned here, please keep this formula in mind. It's very, very important, as I'm going to be using it directly to solve some questions in the later part of the syllabus and when we are doing question review. Now, quickly, let's look into the next slide and solve the questions before us. Very good. Now, the first question here is asking us to have if A cap or A is giving us 2I cap, and we have 2I cap, 4J cap, all these are having cap, note that. And we have B vector is giving us, we have I cap minus 3J cap plus 7K cap. The question asks us to find a dot product of A and B, or you say scalar product of A and B. We just talked about that. We can write our solution here in order not to waste our time. So we can say A dot product of B. We can say it is the same thing as saying we are multiplying without wasting time. The first one is 2I cap. We have a plus 4J cap minus 3K cap. We do that directly. We are multiplying with, I'm putting the dot product here, with I cap minus 3J cap. Then we have plus 7K cap. So doing that directly, we can see because it is just a scalar product, we are less concerned with what within the cross linkage. I will only multiply the i's and i's. I know I and I will give me 1. So I can just say 2 multiplied by the coefficient of this one, which is 1. 2 times 1, everybody knows is 2. I will multiply the second one. You can see very simple, the j's and the j's. 4 multiplied by negative 3 is going to give me negative 12, as j and j will give me 1. That is what we talked about in the previous slide. Now, the last one, I'm multiplying the k's. Minus times plus is still minus. 3 times 7s are negative 21, as k and k is going to give me 1. So directly, we can do this one. And from what your knowledge of mathematics, this is going to give us, very good, this is going to give us nothing but negative 31. As I believe everybody understands how I come about that. So the answer to that is nothing but negative 31. So about the second one, we can quickly do that too. About the second question here, we have before us, the question asks us here to find the angle between the vector of we have 3I cap plus 2J cap plus K cap. Then we have Q is given as an I cap plus J cap plus K cap. Now doing that, angle between vector, we've talked about that, is given as, remember the formula I gave you, I said you can always write the formula down, cos theta, it is the angle between the vector, is always equals to the vector itself over the magnitude. That is the formula I gave in the last sheet. But if you look at the vector we have P and Q. So if you change this to P and Q over P and Q, which is the same thing, my dear student. So that means we are going to multiply the dot product of A and B, like what we did in the first example. So doing that directly, my dear student, we are going to have nothing here but P multiplied by Q. Let's do that at one side here. Because of time, I have 2 minutes more. Directly, we say 3 times 1. That is 3. We say 2 times, and everything is plus. That is plus 2. Then we say 1 times 1 is also plus 1. So P scalar product of Q, or P dot product of Q, is nothing but 6. That means we've gotten the what? The numerator to be 6. So the next thing is for us to go by the what? Magnitude of AB. Remember the magnitude of AB, maybe I should put it there, which is what you remember. Or here in this case is PQ. My dear student, we go by square root of each of them. So please be careful about this, because you need to be very, very careful, because if you are not being careful about this, you are going to make mistake. So now doing that, we can do for what? The magnitude of A, then we do the magnitude of B, then we can multiply them together. I think that is okay if you actually understand what I'm talking about. So these are reasons why you don't need to waste time, or you need to be careful. Let's get the magnitude of P. Let me just do it. The first one I'm doing for P, it will be square of each of them. This is 3 squares. Then we have a plus 2 square. I'm just dealing with the coefficient. The coefficient of this one is plus 1 square. I believe students understand this. This will give us nothing but 9 plus 4 plus 1. 9 plus 4 is 13. 13 plus 1 is square root of 14. That is the what? Magnitude of P. We also do the same thing for magnitude of Q. So which we all know to be square root of all coefficient of that one is 1, 1, 1. We have square root of 1 square plus 1 square plus 1 square. So which is going to give us square root of 3. So my dear students, all values that is needed are now provided. So here we have a formula for angle between vector is cos of theta. A minute more to end the slide. Is now equals to, we have a PQ, and that is a P dot Q over magnitude of the product of the magnitude of PQ. So please keep that in mind, and that is what we are doing. So please, directly we can now put it there by putting the values. Here we have P dot Q is giving us answer as 6 divided by the product of P is magnitude of P is square root of 14 multiplied by magnitude of Q is square root of 3. So you can just put your answer in short form. That is 6 over square root of 14 3s are 52, which I believe everybody can do. If you rationalize, that is mathematics student, that's 6 root 52 over 52. And I think that should be the end of, should be 42, if I'm not mistaken. So it should be 42 and not 52. So this should be 42. You can put that one to the lowest term, and you can calculate the angle. That means cos theta is equals to 6 root 52 or 6 root 42 over 42. Please, this is 42. What I did there was just to rationalize, and you can cut. 6 can go here. I think 6 here 1, 6 here 7. So you can finish it or put it in this form by writing root 42 divided by 7, which you can still write in mathematics as getting theta. If the answer asks for theta, from your trigonometric value, you can say it will be what? Cos inverse of this value, root 42 divided by 7, which you can also write as 6 over root 7. But I don't want to go to the mathematics aspect of it, my dear students, and that is the answer for the angle between the vertical vectors. So be careful about all these type of questions, because you are still going to see more and more of them in future examinations. So guys, see you soon. Have a wonderful time. Bye for